This is Geometry 6.4b, working on coordinate proofs. Remember, we use midpoint, distance, and slope formulas to prove properties of polygons. What we're going to be talking about today is the parallelogram. By definition, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Now there's this symbol that we can use, kind of looks like the real shape of a parallelogram, in front of the four letters. Kind of like a triangle you put in front of the three letters. This is a little parallelogram that implies that this shape is following a parallelogram. We don't have a fun shape for square or rectangle, but you do have one for parallelogram. So you don't have to try to look at this to determine, is that more like a square? Is that a rhombus? That's not the important part. The important part is it a parallelogram? And it's not a triangle, so yes. PQ is parallel to SR, so they both have one arrow apiece, and QR is parallel to PS. And that's because that's the definition of a parallelogram. From that, we can prove other things. We're going to assign coordinates to ensure that our quadrilateral has two sets of parallel sides. So if W is at 0, 0, that's required for standard form, what coordinate would we give Z? What have we done in the past?
0, 8.
A goes sideways, 0 goes up and down. So it has to be the letter first and then the 0, because the 0 implies up and down. So A would be very appropriate. We use A a lot on the x-axis. Now it starts to get weird is over here, this x value. Is there a requirement where this x is located? Thinking about a parallelogram, this point could really be at any location. This side could be at any angle. So it doesn't matter where it's at, and it doesn't matter how far it is. So we're going to use two separate letters here because there is no requirement, at least compared to the A, where that is located. So BC. Now this point definitely matters. Using our sticks, we can see that this point, it's a little bit bigger, it's way out here, but this point can really be at any location. So that's why we called it BC. But notice what happens when we change this point. These down here aren't changing, but that one out here is in a specific location. When the left one changes, the right one moves. So it's going to make a difference where this is at. Let's take a look at this triangle that's being formed right here. What are the dimensions of this? How long is this side of the triangle? How far over is the X point? B. That's the length of B over. How high is that X point? So that is C. We're up C, we're over B to get to this location. So we're going to have this same triangle right here. So that's going to help us determine what this point Y is. Notice that as we slide over here to point Z and we go straight up, we are not at point Y. Point Y is over a certain amount. These gray triangles are the same size. So how much extra are we going over? We're going over an additional amount of B. That if this one went over B, this one is going to go further than the A by that same distance of B. So this is A plus B. What height are we at?
C.
We are at a height of C which is even with X. So what did we just do to determine this? If we think about this as a rectangle, these are right above each other. If I push this side over, we'll call it a distance of B, because that's what our coordinate was here. Distance of B, that's how far over we went. This one is moved over that same distance. So it's the full A plus the B amount that it is slid over. This coordinate here has this A length to it, and it also has the additional B amount to it. So next we can come on down and talk about proving the opposite sides are congruent. Now what are we going to have to do to prove opposite sides are congruent? This is the decision making that you have to make to understand what you're doing. The work itself's not that difficult, but understanding what to do can sometimes be the challenge. So what are we going to need to do to determine if sides are congruent? We're going to look for the distance, and we're going to use the distance formula. The distance formula, remember, is the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. We're going to have to do this a few times. We have to do one for each side. So our first distance that we'll calculate, doesn't matter which side we go to first, let's just make it easy and do Wx. So we're going to take our x value minus our x value. So b minus 0 squared. Our y value minus the y value, which is c minus 0 squared. So that's going to be b minus nothing, that's just b. And square it, I don't really need parentheses anymore. C minus nothing just means c, and square it leaves us with the square root of b squared plus c squared. Now, I cannot simplify that. You cannot take the square root of the squares. It's because of the pluses in the way. So now we're going to find the distance of zy. So we do distance using the distance formula. The x value minus the x value. Remember, when you're doing this, you always want to start with the double letter. If you have one that's being added or subtracted, it's a binomial, then you want to be sure to place that first. So a plus b, that's your x value, minus the other x value. And the y value minus the y value. What do we get? What is a plus b take away a? It's just b, and it's b squared. So here we have c minus nothing. That's just c, so c squared. They are congruent. Look at that. These are the same. So what we know for sure is that wx is congruent to zy. Because our distance formulas were the same. Okay, now we're going to move on to our next set of points. So now we're going to figure out xy. We don't put a line above these. I almost did. Equals. Okay, now again, notice this has the two letters, so we don't want to start with the b. We don't want to subtract the two letters. We want to start with the two letters. It just makes the math a little bit easier. So we're going to say a plus b minus b squared, and the c minus c. So what's that going to be? How do we do this? How do we do a plus b minus b? How am I supposed to know what that is? A plus b minus b. The b's are going to cross out, and we're left with just the a, and the a is being squared. C minus c, that's 0, and that's being squared. So we just have a squared. So if we have a squared, and it's being square rooted, what is the square root of a squared? Very good, it's a. Think about the number 9. The square root of 9 is made up of 3 times 3, which is 3 squared. So the square root of 3 squared is 3. The square root of 9 is 3. So in this case, the square root of something squared is that something. All right, so that's the length of A. How about this one? What's the length of WZ? Well, we take our x value minus our x value and our y value minus our y value. That leaves us a minus nothing, which is just a, and it's being squared, plus 0 minus 0, which is nothing, squared. So that's just the square root of a squared. And if you're taking the square root of something squared, it's just that something. So these are the same. So WY, or let's call it WZ, WZ is congruent to XY. So we showed both sets of opposite sides are congruent. That's how you do it. Just a distance formula. Working with letters. Taking your time. x2 minus x1 squared plus y2 minus y1 squared. Okay, diagonals. How do we prove diagonals bisect each other? What's got to be done? What's the work that needs to be done to show that diagonals will bisect each other? First of all, you need to know what diagonals are. There's a diagonal, and there's a diagonal. So if they're going to bisect each other, they're going to cut each other in half. That means they both have to have the same midpoint. Notice that these diagonals are not the same length. This one is over 1.5 centimeters. This one is just over 4.5 centimeters. So they are not the same length, but they can still have the same exact midpoint. Let's see if that happens. So we're going to find the slope of xz. Not slope, sorry. We're going to find the midpoint of xz. So using those points, we add the x's together, divide by 2. We add the y's together and divide by 2. That's going to give us a plus b over 2, comma c over 2. That's the midpoint of xz. And then we're going to find the midpoint of wy. That's the other diagonal. We're going to use these coordinates. So x plus x and y plus y. A plus b plus 0 over 2 and c plus 0 over 2. That's a plus b over 2 and c over 2. What do you know? Same midpoint shows diagonals bisect each other. Using letters when we use the distance formula and when we use the slope formula. All right, last one. We're going to assign coordinates to this quadrilateral to ensure that we have right angles. Well, we know that W is 0, 0. It's at the origin. Z is a distance to the right. It doesn't matter what that distance is. So we're going to call it A, but it's on the x-axis, so we're at 0. A, 0. Point X is on the y-axis, so it's right and left nothing. So it's at 0, comma. If this is a rectangle, it doesn't matter how tall it is. So we use a different letter. It's not related to Z. It doesn't have to be the same as Z. It doesn't have to be half the Z distance out. So what is this point? It's the distance of Z, but it's the height of the X. So it's the A value, comma, the B value. Those are our coordinates for a rectangle. To show it's a parallelogram, we're going to show the slope. We have two sets of slopes that are the same. Slope of WX or XW slope is y minus y and x minus x. What do we get when we have something over 0? We abbreviate that as undefined as UND. Undefined. It's straight up and down, and that's what would be true about a rectangle. The slope of WZ, or YZ this time, YZ would be the y value minus the y value and the x value minus the x value. B minus 0 and A minus A. So the calculations, notice, are a teeny bit different. But it's still B over nothing. Doesn't matter what's on top. If the denominator is 0, it's undefined. So that means this slope is straight up and down. Undefined. That makes them parallel. Okay, then we have our two other slopes over here. XY. That's going to be B minus B and 0 minus A. That's 0 over negative A. That's a slope of 0. WZ is going to be the y values. 0 minus 0. 0 minus A. That's 0 over negative A. It doesn't matter what the bottom is. If the top is 0 and the bottom's not 0, then this is 0. So we know that XY is parallel to WZ. This last one, we need to find, to show the diagonals are congruent, we're going to find the distance formula for both of those. So the x value minus the x value squared, and the y value minus the y value squared. That is our WY. XZ is going to be the y value minus the y value squared, and the x value, or those were the x's, the y value minus the y value. When you square a negative, you get a positive. B minus nothing squared is B squared. Can't simplify.
Yeah.
That shows you these are parallel, congruent. Distances are the same, segments are congruent.